Projects, well, we have many projects. Now, one other aspect that I should have mentioned in the why choose Fresno State, just as proof that what we're claiming is true. So only a few weeks ago, every year there's an annual competition. It's called the American Society of Civil Engineers Mid-PAC, which is the Mid-Pacific Group of Schools competition. And in this competition, there are many sub-branches. There's the concrete canoe, which is the most famous, steel bridge, which is the second most famous, and then there's the water quality competition, and there's the transportation competition, and a few other ones. Now, this year was the first time in our history that we participate in the transportation competition, and we were competing against good schools. So Tongji University from China, which is very famous for their transportation engineering program, they have a Bachelor of Science in Transportation Engineering. That's how strong, that's how focused they are. Their students study nothing but transportation engineering from freshman to senior. They were participating, UC Davis was participating, and I think 5 or 6 other schools. This was this is not the first time these other schools participate. Every year, 1 or 2 or more schools participate in this challenge, but it was our first time, and we got first place. This is just a reflection of the good work or the unique work that we're doing here at Fresno State. Now, transportation research projects that are going on, we have many. So, as I mentioned, we have several students working on research related to autonomous vehicles and their impact in our region, and this reflects their impact almost anywhere else. So, our region is just a case study. We have students working on emissions. So as you know, air quality is our biggest challenge in the region. So we have students working about using different models to estimate emissions coming from gasoline and electric vehicles. So most people are not aware that electric vehicles do produce emissions. Only difference, they do not produce them on the road, they produce them at the electric power station. Plus, there is also emissions. One of the problems or the challenges with electric vehicles is the battery. So the battery is to produce these batteries, as well as to get rid of these batteries, to produce them before the lifetime of the vehicle, or get rid of them after decommission them after the end of the life of the vehicle. This adds emissions. So the factory that produces these batteries, as well as the factory that gets rid of these batteries, they produce emissions. So we have a student who has been working on emissions, and he gave a presentation last week in an international conference in San Diego. We have students working on artificially intelligent traffic lights. So how can we make traffic lights more intelligent enough so that they can on their own sense the traffic patterns and respond in a manner that minimizes people's delay. We have students working on, that's the grant I mentioned from the Federal Highway Administration. It's about understanding travel behavior. So we're trying to see what new transportation technologies are appearing, and what types of data do we need to collect to understand these new behaviors. Examples are vehicle and ride sharing and sourcing companies like Uber and Lyft and similar ones. So how are these affecting our travel behaviors? Online shopping is another interesting example. So many years ago, when transportation engineers and researchers were under the impression that the internet is going to reduce travel, because now I can, instead of going to buy something, I can just make this order online, and then the UPS truck will gather all of our orders and deliver them in just one long trip, and this would decrease congestion. Now what we're discovering today is it's the opposite. So this online shopping is increasing congestion, because in the past, if I were to buy 10 different things, I would combine all these 10 items and I would go buy them in just one trip. So I'll make one trip in a week and up to the mall, and I'll get my 10 items and come back. What we're discovering now is that people are making, now these 10 items are being ordered. I will order 8 and I will still make this same trip to go and buy these 2 other ones. So my trip, I'm still making the same travel. But in addition to my existing travel, now I have the UPS company making extra travel to deliver my 8 other items. So this is actually increasing congestion. So, and that's the idea of the project that we're working on for the federal government. Another project that we're working on is food deserts. So what's the impact of living away from a grocery store on grocery shopping habits and the types of foods and nutrition and diet? How does this affect your health? Other project that we're working on is we're doing a simulation for railway signal preemption. So if there's a traffic light close to a rail line, then there is a specific procedure that the traffic light should follow when it senses the presence of a rail line, to make sure that the tracks are clear, to make sure nobody gets stuck on the tracks of the rail line. We're doing some projects for the school about usage of bike racks. We're doing projects about the active transportation on campus. We're doing projects for the so we have been discussing working on a project with the Central Valley Health Research Institute about the impact of the increase in urban density, which is the direction that our city is going towards, hoping to reduce climate change emissions and energy consumption of our city. On the other hand, we're exploring what, by increasing urban density, it is expected that traffic congestion, concentration of traffic is also going to increase. And as the concentration of traffic increases, the concentration of air pollution emissions from vehicles is also going to increase. And we're trying to explore whether there are any relations between this increase of concentration of air pollution reflected as increase in exposure of inhabitants to air pollution emissions, and see if there are any relations. So these are examples of some projects. They're not all of them, but they are the examples that come to mind at the moment. What's exciting to me is it's a new world. It's new technology. It will change everything. So at the moment we are designing, or we are discovering how this new world is going to be. It's a new life. Uber is changing the way we live, which is a ride sourcing technology. When autonomous taxis come into our lives, this will change a lot. So imagine you do not need to own a car anymore. What you can do is, if you want, in the morning, you'll just pick up your phone, request a vehicle, open the front door, a vehicle is waiting for you, you hop in, it takes you to your exact destination, you hop off, it goes away. There's no hassle for parking, there's no hassle for worrying about the vehicle may not start or something may happen. It will be cheap, so it is expected that these will be the new buses. So it's expected that there won't be any buses any longer. So these vehicles will replace our transit systems, autonomous taxis or autonomous vans. So the research that we're doing right now is we are trying to discover, we're trying to foresee a life that isn't here yet. So this discovery is very exciting for me. But also, after we discover this, how are we as a society going to design this life? After we discover how this life is going to impact us, then how do we want, so some of these impacts, like every technology, there are positive impacts, there are negative impacts. How are we going to address these negative impacts? How are we going to design our lives to counteract these negative impacts? So for me, that's very exciting. When are you getting your jetpack?
Yeah.
Well, they're not coming. One of the biggest problems in transportation engineering, and our consistently first priority, is safety. Only in the United States we have 40,000 people dying every year because of traffic accidents. Worldwide, that's 1 million. Now, these 40,000 individuals is is a lot. This is equivalent to one airplane, mid-sized airplane, 200 passengers, crashing every day, and 100% all the passengers on this plane dying every day. So there's 40,000 people dying on our highways every year is equivalent to one mid-sized plane crashing with all fully occupied, all seats are occupied, and every single person on this plane dies every day. Now, if you think as a society, what do we do when a plane crashes once a year? It's all over the news. Everybody's talking about it. But for some reason, our highway safety is not considered with the same level of attention. But this is a big problem. 40,000 people are losing their lives for no reason every year because of traffic. And this is only in 2 dimensions. Can you imagine how worse the situation would be if people were to use the 3rd dimension and fly? I do not think, for this reason, I do not think that jetpacks are ever coming. They may one day come but once they become completely automated as well. When our technologies and our algorithm can ensure that can control 3D movements for many agents at the same time in the same space without causing any discomfort or safety problems. But we have to successfully do it in 2 dimensions first, which is autonomous vehicles. And after we succeed in 2 dimensions, we can start exploring the 3rd dimension. So probably, I don't know, maybe 200 more years. I want to thank you for doing this interview and for building a website for other students and interested personnel from our Central Valley or our state or anywhere else in the nation or the world. I think Fresno State has a lot to offer, and I think we are growing. We are in the process of hiring another professor, another transportation engineering professor. Hopefully the search happens and the interviews will happen next year, and hopefully they will start here in August 2016.
Oh, it's exciting.
It is. It's a very exciting time for us in Fresno.